Hi everyone, welcome to the Tech Master. Today I'll be talking about pre-order traversal. So what pre-order traversal is? Pre-order traversal is node, left and right. So first we will visit the node, then we will visit the left side of the node, and then we will visit the right side of the node. And we follow this rule for all the nodes. Let's run pre-order traversal on this tree. So here we will start with root node. Root node is one, and the pre-order traversal is node, left and right. So first we will be visiting the node. So we visit node 1 and then we move on to the left side. On the left side, we have node 2 and now we'll be visiting this node. After visiting 2, we move on to its left side, and on the left side, we have node 4 and now we visit node 4. And now we move on to the left side of 4. So on the left side, we have null and we have visited node 4 and left is null. Now we move on to the right side. So right side for 4 is also null. So now we go back to 2. So we already visited node 2. So left side is visited. Now we move on to the right side. So on the left side, on the right side, we have node 5. So we visit node 5. And then we check the left side of node 5. So left is null and right is null. So if we look at node 2, we have visited node 2, then we visited left, that is node 4, then we visited right of node 2, that is node 5. Now we go back to node 1. So for node 1, we have visited all the left side nodes. Now we move on to the right side nodes. So from 1, we move to node 3 and we visit node 3. So after visiting node 3, we move on to its left side and we visit the node. So we visit node 6. And for node 6, left is null, right is null. So we have nothing to visit. Now we go back to 3. So for 3, we have visited the left side 6. Now we move on to the right side of 3. So that is node 7. So we visit node 7 and we have visited the whole tree. So, so the pre-order traversal for the given node is 1, 2, 4, 5, 3, 6, and 7. This is the code for pre-order traversal of a binary tree. Here I have defined a pre-order traversal class that has one method traverse that will take the binary tree root as the input and it will traverse the binary tree in a pre-order fashion. So let's see what this code looks like. So here we are expecting the binary tree node that is a root node, and we won't have anything to traverse if the root is null. And if root is not null, we traverse the root node. Here we are doing this system.out.println. We are just printing the node data. So this is what we are doing as part of our traversal. It can be some other operation also. And then we move on to the left side. We call the same method again in a recursive way. We move on to the left side, and once we are done traversing on the left side, we will move on to the right side. So we say traverse root dot right. Let's see how this code will work on top of the tree that we discussed. I'll be running this code on top of this tree, and we will start with root node 1. So root node reference will be passed to this traverse method. So root will refer to that root node, and root is not equals to null. It will not go inside the if block. The control will move to the line number 5 where the root data is printed. So we started with node 1 and with line number 5, node 1 will be printed. And with line number 6, the control will move on to the left side of node 1. So left node of node 1 is 2. So from the line number 6, traverse method will be called with node 2. So we are on node 2 and node 2 is not null. And yeah, so I'll just write here. So root is referring to node 2 and node 2 is not null, and with line number 5, node 2 will be printed. So we have traversed node 2. And with line number 6, the control will move onto the left side of node 2, that is node 4. So for node 2 left is 4, and now node 4 is passed to the traverse method, and root is not null, node is not null, and will be printing node 4 will be printed out, and the control will move onto the left side of node 4. So left side of node 4 is null, and so on from the left side of node 4, null will be passed to the traverse method, and now root is null and it will return from there. So the control will be returned from the left side of node 4, and now for node 4, line number 7 will be invoked where the right side of node 4 will be passed to the traverse method. So right of node 4 is also null. So So null is passed to the traverse method from the right side of node 4, and root will be null, so it will be returned. No processing will happen. Traverse method is all executed for node 4. Now we will just be removing node 4. So we are done for node 4, and for node 2, line number 6 is executed from the line number 7. Node to write will be passed to the traverse method. So node to write is 5, and yeah, we have already traversed node 4. For 5, so let me just mention it. So for node 5, node is not null, and from the line number 5, 5 will be printed. So we have traversed node 5. For node 5, left is null. So from line number 6, null will be passed to the traverse method and it will be returned. And from line 7, null will be passed to the traverse method and it will be returned from line number 3. So we have visited the left side of node 1. We have visited node 1, 2, 4, and 5. Now we'll move on to the right side of node 1. So on the right side of node 1, we have 3. So we move on to the right side of node 1, 3, and 3 will be passed to the traverse method, and 3 will be visited. So we visit node 3, and 3 left is 6. So from line number 6, 6 will be passed to the traverse method, and 6 will be visited, and 6 don't have any left or right node. So those for those nodes, it will return from line number 3, and 3 the right is 7. So for 3 we have visited left side, we will be visiting right side. For 7, root is not null. We will be visiting root 7 or node 7, and 7's left is null, right is null. So traverse will just return for those null values, and we have visited the whole tree, and the pre-order traversal is 1, 2, 4, 5, 3, 6, and 7. So what's the complexity for the pre-order traversal? Time complexity is big of n because we are visiting all the nodes of the tree, and the space complexity is big of h if we consider the memory stack count for this pre-order traversal method.